So today we're going to develop, or not develop, but I'm going to show you these identities for the sum and the difference of two angles for sine, cos, and tan. A first question I want to pose to you. Is the sine of 30 plus 60 the same as the sine of 30 plus the sine of 60? I want you to pause the video for a second and think about that. Think about whether or not that is a true sentence. Is the sine of 30 plus 60 the same as the sine of 30 plus the sine of 60? Hopefully, you've taken a second to think about that and to reason through in your mind an argument for yes, they're the same, or no, they're not the same. And because I'm not there with you, I can't really pick your brain, but I will tomorrow. And I will be looking for somebody who can give me a valid and intelligent argument as to why these are not the same result. And the most, what's the word I want? Logical? Keep in mind, you cannot distribute a function across a binomial. This is not multiplication. And so I would tell you, is the sine of 30 plus the sine of 60 equal to the sine of, or equal to the sine of 30 plus 60? My gut would tell you no. But I'm going to prove it through an identity proof. And what we do for that is we draw a line here under the equal sign because I don't want to claim equality until I know for sure. Now, here's the thing. 30 plus 60 is 90. And the sine of 90, we all know, hopefully, is 1. We can get that off of our curve, our trig function. The sine at 90 is 1. That's where it peaks. I can get it off my unit circle. I can get it from my calculator, whatever. We also know from our special angle ratio chart that the sine of 30 is 1/2, and the sine of 60 is radical 3 over 2. Now, you don't have to be a rocket scientist to realize that 1 plus radical 3 over 2 is not 1, or 1/2 plus radical 3 over 2. So when I look at this and combine them into a common fraction, that is definitely not the same. So I can say, no, they are not the same. So how would I do the sine of 30 plus 60 then? Well, 30 plus 60 I wouldn't. How would I do the sine of, let's take a look at, just a little warning here, because that reference angle piece that I was using works great, unless it looks like this, because what's happening here is pi over 2 is 90 degrees. And if you start with 90 and add theta, you're actually going to be here. Okay, so you have to be really careful that you don't say, oh, that's the same as the sine of theta, because it's not. Because what happens when you do this expansion, and again I'm going to use theta for A and 90 for B, this will be the sine of theta cos of 90 plus cos of theta sine of 90. Here's my 1, which means this is my 0, and that's gone. This is the same as the cosine of theta. And it's because theta's here, this would be the co-function piece. You got to be really, really careful that you don't fall into that with 90 degrees or 270 even. So the identity is the safest way to go through those. Okay. We will be looking at other ways that they can use these sum and difference identities, and we haven't done a tangent yet. Tangent works the same way. You just substitute in and simplify it. You have to be careful of the undefined values, because remember, tangent at 90 is undefined. But other than that, you know, it's really pretty much the same. This one, sine of 75. This is actually a fairly common question, to find the exact value for the sine of 75. Now, we all know we didn't do exact value ratio charts for 75. We did 30, 45, and 60. We also know our quadrantals. We know our 90, our 180, or 270, etc. But the sine of 75, I could actually break that into the sine of 30 plus 45. Because I know the sine of 30 and I know the sine of 45. Here's the problem. It's not equal to the sine of 30 plus 45. I just proved that with the sine of 90, that it's not equal to the sine of 30 plus 60. So that means I have to have my identities. Now I'm going to tell you that I am not, this is the only time that you will ever have me give you a formula that we do not derive together. The derivations are not easy to follow. If you want to look at them, you can, I'm sure, find them online somewhere. If you Google the cosine for the sum of two angles, you will find a derivation, and then from that you can springboard off into the difference and the sines and the tangents and all that. It is truly not worth the time and the effort and the confusion factor for me to do that for you. The other thing is, these formulas are given to you on the reference sheet on the Regents exam. So what I'm going to do is just give them to you now. We're going to put them in a notebook, and then I just really need to show you how to use them. Okay, so here they are. There's 6 of them. There's 2 for sine, 2 for cos, and 2 for tan, because there's a sum here. There's the sum of the angles for sine and the difference of the angles for sine, a sum of the angles for cos, difference for the angles for cos, sum of the angles for tan, and difference of the angles for tan. One of the nice things about this, though, is that you're going to see patterns. And these patterns, and what I did was I just put the changes in red to make them stand out. So the pattern for the sine of either the sum or the difference is sine of A cos of B, cos of A sine of B. So there's a sine and a cos in each of the products, and then basically the angles just swap. So in the first product, sine of A, cos of B, so it's sine of the first, cos of the second, cos of the first, sine of the second. If it's the sum of the angles, you put a plus sign in there. If it's the difference of the angles, you put a minus sign in there. So it's pretty simple to remember. And again, these are on the reference sheet. They don't have to be memorized this year. Next year in pre-calc is a whole nother story. But for this year, they will be given to you. You just have to know A, they're there, and B, how to use them and when to use them. Okay? So again, the sine pattern is sine cos, cos sine. If you're adding, it's a plus. If you're subtracting, it's a minus. That's the only difference between these two. The cosine pattern is different. Cosine is going to say cos of A, cos of B, and then sine of A, sine of B. So you're multiplying a cos times a cos ratio, and then a sine times a sine ratio. The tricky part is when you're adding the angles, so when you're taking the cosine of the sum, you subtract the products there, the terms. And when you're taking the cosine of the difference, you actually add. So that's an important piece to remember. When you're adding, when it's a sum, you subtract, and when it's the difference, you add. Now, tangent, remember, is the ratio of sine over cosine. And so if I took the tangent of A plus B, if I took the sine of A plus B and divided by the cosine of A plus B, and then manipulated it to get common to blah, 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 what I would end up with is this piece here. Tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. And again, for the sum, the numerator gets the plus, the denominator gets the minus. And for the difference, the numerator gets the minus, the denominator gets the plus. Other than that, the terms are the same. Again, no need to worry or panic. These are given to you on the reference sheet. So you will never be expected to know them on your own this year. Okay? Anytime I test or quiz them, you will have them. So let's go back to this problem where I want the exact value for the sine of 75. And so I'm going to break that into 30 and 45 because I know those ratios, 30 and 45. Now my sine identity for the sum of two angles, and I'll write it again. The sine of A plus B is the sine of A cos of B plus cos of A sine of B. So what that means is if I call this A, and I call this B, wherever I see an A, I'm going to put a 30, and wherever I see a B, I'm going to put a 45. So I'm going to simply substitute. It'll be the sine of 30 times the cos of 45 plus the cos of 30 times the sine of 45 from my special angle ratio chart, which hopefully by now you know. If not, you better have it written down somewhere, or you better have it for reference. Sine of 30 is 1/2 cos of 45, radical 2 over 2. Cos of 30, radical 3 over 2. Oops. Sine of 45, radical 2 over 2. So remember, I'm multiplying these. And so multiply the numerator, multiply the denominator, you get radical 2 over 4. And I'm multiplying these. When you multiply radical 3 by radical 2, you get radical 6. And then 2 times 2 is 4. The beauty here is that the denominators match, so I can actually combine them into a single fraction. But because the radicals are not like radicals, I cannot combine them. And so my answer turns out to be radical 2 plus radical 6 all over 4. And I know that that is a gross answer, but that is the exact value answer for the sine of 75. If you were to take your calculator and convert the square root of 2 plus the square root of 6, and then divide that answer by 4, you will get the exact same answer as if you take the sine of 75. And both of them convert to 0.965925823, etc. Okay. This is the decimal version, though. This is not going to get you credit. This is what gets you credit right here when they want exact value. This is a pretty typical question. Very popular, as a matter of fact. They want you to simplify the cosine of theta minus pi over 2. Now, pi over 2 we know is 90 degrees. And I'm going to actually convert that to 90 degrees because it's easier for me to work with the degrees than the radians. Well, maybe not for me, but for you, certainly, okay? But this is the difference of two angles, and that's the key to this. Again, we're not going to just distribute this cosine through this binomial. We already know that doesn't work. So when I go to my reference sheet and I pull my conversion formula, this is going to be the cosine of the difference is the cos of A, cos of B, plus, be careful there, sine of A, sine of B. And again, I'm going to use theta for A and 90 for B. Okay, so theta I don't know, and that's fine. I'm just simplifying it. I'm not evaluating it. Notice the directions. Simplify. So what I'm going to do is put in the cos of theta, because wherever I see an A, I put a theta, cos of 90. And that can get converted because I know that. That's a quadrantal. Plus sine of theta, sine of 90. And that's going to get converted. Now here's the beautiful thing. Cosine of 90 and sine of 90, one of them 0 and one of them is not 0. Because at each quadrantal, one of the coordinates is 0, either sine or cosine. So one of these terms is going to totally disappear. Cosine of theta times cosine of 90 is 0. Plus sine of theta, sine of 90 is 1. So what happens is this whole thing just goes away. And my cosine of theta minus pi over 2 simply simplifies to sine of theta. Answer. Okay. Here's another one. Sine of theta plus pi. Same idea. I'm going to use for A, theta, and for B, pi, which is 180 degrees, because it's, again, easier to think in terms of pi. And so the expansion looks like this. Sine of A, cos of B, plus cos of A, sine of b. There's no trick to this. I am simply pulling that right off the reference sheet. So all you're doing is writing it down, and now I'm going to substitute. So it'll be the sine of theta cosine of 180, which will get replaced, plus cosine of theta sine of 180, which will get replaced because the quadrantals, I know those values. So sine of theta cosine of 180 is negative 1. Cos of theta sine of 180 is 0. This one drops, and my final answer is a negative sine of theta. Beautiful. What I want to do is just take you through a little bit of the reasoning on this. If I have an angle theta plus pi, let's think about that, where that is. Theta plus pi. Pi is 180, right? 180 plus another angle theta will actually put me into quadrant 3. So here we are here, right? So here's my pi, here's my theta, here's my 180. And so if I think about this in terms of reference angles and my whole QRS, and the fact that in quadrant 3 sine is negative, this will be the same as the negative sine of theta. And so that really is where the development of these formulas come from, is through the whole reference angle and is it positive, is it negative. The positive and the negative is built right into the formula, so you don't have to worry about that. But this is the connection. Hopefully that makes sense to you. Okay, one last example for us. Cosine of pi minus theta. And so it's going to be the cosine of the difference of angles pattern, which you're going to pull off of your sheet. So it's going to be the cosine of, I'm going to write down the formula first, cos A cos B plus sine A sine B. Please make sure you're pulling the right identity. So it'll be cos pi cos theta plus sine pi sine theta. Now remember that pi is 180. And I probably should have written that, but pi radians is 180 degrees. So this is really the cos of 180. I could have saved myself a little time had I just substituted that appropriately. Cos of 180 is negative 1 times the cosine of theta. Sine of 180 is 0. So this is just going to go away. So my answer is going to be the negative cosine of theta. But again, if I look at it in terms of a reference angle, here's pi, here's 180, minus theta puts me into quadrant 2, where cosine is negative, and my reference angle is theta. So it's the negative cos of theta. I just want you to make that connection, that's all. These identities will never let you down.